In this video, I'll explain in very simple layman terms of why increasing CO2 to 800 ppm will only increase global temperatures by 0.7 degrees Celsius. This is the most technical video that I'll ever do. Yes, follow the science. If climate alarmists can follow the science, they'll be very upset. If climate alarmists can understand the science, they will be very upset. This video is a demonstration to climate alarmists that I know more climate physics than you. Not only am I an intellectual snob, the longer as time passes, the longer you climate alarmists live, the longer I live, the longer we live, you'll be forced to admit that the world is not boiling, it's not ending, and that human lives are getting better and better, and the world is getting better and better.
Raising CO2 from 400 ppm to 800 ppm only increased temperature by 1%. This is a layman guide to climate physics, so let's break it down step by step. This is real education. So this is the basics of greenhouse effect. I'm simplifying this in order for us to orientate. So coming down is the energy coming down from the sun and it's reflected, and this is on the right, we have the energy going back from Earth to space. So on the way up to space, there is this thing called greenhouse gases. So some energy is being trapped here by greenhouse gases and not be able to be reflected back to space. This is the Planck's black body curve. When we look at the y-axis, it's the energy going up from Earth back to space. When we look at the y-axis, it is the energy going up at different wavelengths of radiation. Assuming there are no greenhouse gases, this is the energy that is not trapped and freely going back up into space. The area under the curve is the total energy going up to space if there are no greenhouse gases. And the area under the curve works out to be 394 watts per meter square. That's the total area under the curve. This is the total energy that's going up to space if there are no greenhouse gases. Here are the top 5 greenhouse gases, namely water vapor, CO2, nitrous oxide, ozone, and methane. So as you can see, different greenhouse gases absorb energy at different frequency due to the ways the molecules are arranged, the way the molecules spin and turn when they are being hit by energy. So the smaller area under the curve means less energy is escaping from Earth. As represented by the blue curve is the total energy that's escaping from Earth, and now we look at the black curve. The black curve is when there's greenhouse gases. Energy going up is reduced from 394 watts per meter square to 277 watts per meter square, as represented by the black curve. And the black curve represents the current state of 400 ppm of CO2. When we increase CO2 from 400 ppm to 800 ppm, the amount of energy escaping from the Earth is reduced from 277 to 274, as represented by the red curve. So the red curve is here. There's barely any difference, but there's a difference of 3 watts per meter square that is not escaping, that is being trapped because of the increase to 800 ppm of CO2. So raising CO2 to 800 ppm will only stop 3 watts per meter square of energy from escaping the Earth. And if we work it out, that will translate roughly to 0.7 degrees Celsius. Meaning to say, if we increase CO2 from 400 ppm to 800 ppm, global temperatures will only increase by 0.7 degrees Celsius. So this is not just a set of models and equations and predicting into nothing. Garbage in, garbage out, assumption that is just as good as the conclusions. So this is certainly not the case. All these calculations are being verified by the HITRAN database. And the HITRAN database is a repository of molecule observations reacting to different wavelengths of radiation. And what we have gone through is William Happer's papers, who made use of Max Planck's black body curve, and Carl Schwarzschild's works. For an even more technical explanation, please refer to the original video, and the link to the paper is in the description. The greenhouse effect is more complex and more nuanced than believing in a linear exponential runaway warming. Man does contribute to global warming, but very little and very negligible. Special thanks to the Honorable William Happer for writing this paper and presenting it to us.